We're going to start out today with a trigonometry overview. Trigonometry is going to be really important in this class. We're going to use it for calculating coordinates of points. And then we're going to see that when we start thinking of certain things as vectors, we're going to use the exact same approach for calculating what are called components of vectors. For now, you can just think of it as calculating points, the coordinates of points. So, okay, let's start with a right triangle. A right triangle means one of these angles is 90 degrees. And we're going to pick one of the two other angles. It doesn't matter which one. This works either way. Let's say that this is the angle that we're going to be considering. We'll call that angle theta. And based on choosing that angle, we're going to call, well, no matter which angle we chose, the hypotenuse would be that diagonal side. And then we're going to call the one that, there's two sides remaining. The one that's in contact with the angle we chose is going to be called the adjacent side. And the one that's not in contact with the angle we chose is going to be called the opposite side. And really all you have to know is so, ka, toa. So that's just a memory device. You probably remember this from a math class. The so part means the sine of the angle is equal to the opposite over the hypotenuse. Ka means that the cosine of the angle is equal to the length of the adjacent side over the length of the hypotenuse. And toa means that the tangent of the angle is equal to the length of the opposite side over the length of the adjacent side. Okay, so for example, to use these, say that you had a right triangle where you knew this angle was 20 degrees and you knew the length of the hypotenuse was 10. And let's say you wanted to calculate the lengths of those two sides. Well, you can use this SOHCAHTOA idea. You know that the sine of this angle 20 degrees is equal to the opposite of that angle divided by the hypotenuse. So that's b over 10. If you look it up in your calculator, the sine of 20 degrees is 0.342. And so 0.342 is equal to b over 10. Now it's just algebra to solve for b. And you get that b is equal to 0.342 times 10, or b is equal to 3.42. We're going to use the fact that the cosine of 20 degrees plug it into your calculator. Remember, you need to have your calculator set in degrees instead of radians. And so if your calculator is set in radians, you're going to have to go to a mode button on your calculator. But cosine of 20 degrees is equal to the length of the adjacent side divided by, length of the adjacent side divided by the length of the hypotenuse. The cosine of 20 degrees is 0.940, and that's equal to a over 10. And then, again, it's just algebra. A is equal to 0.940 times 10. And so A is equal to 9.40. So to use this when you're dealing with coordinates of a point, you just need to also take into account, so we're going to set up right triangles to help us deal with coordinates of points. The point of the triangle, this spot over here, is always going to be at the origin of your coordinate system. And we're just going to use this SOHCAHTOA idea to deal with points. To do that, the only other concept you really need is, so if we have a coordinate system, and for now we're always going to use coordinate systems where the positive x-axis is to the right and the positive y-axis is up. Okay. Anything that's on this side, so in either of these two quadrants, this one, you might remember as the first quadrant, this one's the fourth quadrant. These are all positive x values. And anything over on this side is negative x values. And you can use a similar idea to break up this coordinate system, if this is x and this is y, into positive and negative y values. Anything above the x-axis Okay, so let's see a couple of examples of using this SOHCAHTOA idea to calculate coordinates of points. And if we have the coordinates of points, we can use it to calculate some other things. So the first example is, let's say we have a coordinate system like this. And we're looking at the point, let's say that this is the point. And we know that if we draw a line from the origin of the coordinate system to that point, the length of this is 20. And let's say that we know that the angle between the x-axis and this is 20 degrees. Okay, and we want to know what are the coordinates of that point. Let's call this point P. So how are we going to do this? Well, we're always going to think of making a right triangle. And now that right triangle that goes like this, if you can see my cursor, we can use SOHCAHTOA with that. And then we have to think about the coordinates, the signs of the coordinates. The x coordinate of this point P is going to be the length from the origin to where this red line intersects. It's going to be that adjacent side. That is going to be annoying as time goes by. Maybe I can figure that out. This software, they just changed all this software, so I'm trying to get used to it. Okay, so to calculate the x coordinate, we know that the cosine of 20 degrees is equal to the adjacent over the length of the hypotenuse. And so 0.940 is equal to the adjacent over 20. So the length of that adjacent side is equal to 20 times 0.940. And that is 18.80. And now we're going to, and so we know that our x coordinate is going to be either plus or minus 18.80, depending on whether we're in the region of positive x values or negative x values. We're over here on the side of positive x's, so we want the positive here. And now we'll do a similar thing for y. We know that the sine of 20 degrees is equal to, you can see for this one, we want that red line length. And so the sine of 20 degrees is the opposite over the length of the hypotenuse. And so that says 0.342 is equal to the opposite over 20. So the length of the opposite side, the red line, is equal to 20 times 0.342. And so if you multiply that out, that is 6.84. Well, the y value is plus or minus 6.84. And then you have to think, is the point we're looking at in the location of positive y values or negative y values? This is positive. And so again, we're going to take the positive. And if you put this together, what you get is the coordinates of P are 18.80 for X, positive, and positive 6.84 for Y. And so those are the coordinates. Okay, let's do one that's in a region where everything isn't positive. And this time, I'm going to try to walk you through it step by step. So what I want you to do is I'm going to tell you at each point where I want you to pause this and go through this yourself to make sure you're getting these steps. So this time, if this is our coordinate system, our point P is going to be here. And we know that the distance from the origin to P is 5. And we know that this angle is 50 degrees. Okay, so The first thing you need to do is figure out a right triangle that has the angle you're given in it and calculates the lengths of the x and y coordinates that we're looking for. We'll think about the signs in a second. So pause the video for a second and then draw in those lines. Okay, well, this is going to be the length we want in order to calculate the x coordinate, and this is the line we're going to want to calculate the y coordinate. And now use SOHCAHTOA to find the lengths of those two lines. So pause the video and see if you can do that. All right, so to calculate the length of the green line, you can see that that's the adjacent side for this 50-degree angle. So we have that the cosine of 50 degrees is equal to the adjacent side divided by the hypotenuse, which is 50. The cosine of 50 degrees is 0.643, and that's equal to the length of the adjacent side divided by 5. And so what we get is that the adjacent side is equal to 5 times 0.643. And that's something around 3.21, let's call it 0.215, I guess. In this class, I really don't care about significant figures. You don't have to worry about how many decimal places you keep in your calculations. I just want to see you doing these calculations with the right approach. And then, so that was the green length. Now we want the red length. So pause the video and use SOHCAHTOA to calculate the length of the red side. This time we have that the sine of 50 degrees is equal to the length of the opposite side divided by 5. And so if you plug sine of 50 into your calculator, you get 0.766. That's equal to the opposite over 5. Do the algebra and you get that that opposite side, the red side in the picture, is equal to 5 times 0.766. And that should give you, let's see, about 3.83. Okay, now you have to think about the signs of the coordinates. So pause the video for a second and see if you can figure out, we know that the magnitudes of the coordinates are 3.215 for x, 3.83 for y. Now you just have to combine it with the signs to come up with the coordinates. So take a second and see if you can do that. Okay, well, you can look here and you can see that this point P is in the region of negative x. It's also in the region of negative y. And so the point P has the coordinates negative 3.215, negative 3.83. Okay, well, let's keep going with this. Let's do an example where this is our coordinate system. And the point we want is here. So this is the point P. And we're given that this distance is, I want to do a different kind of example here. So instead of being given the distance from the origin to P, let's say that what we know is this length. We don't know this length. We don't know this length, but we do know that this angle is 10 degrees. Okay, so let's say that we're given that the length of that green line is 4. And so the question is, can we calculate the coordinates of that point P? Well, the first step is to calculate the length of that red side. So see if you can use SOHCAHTOA to calculate the length of that red side. And pause the video and do that. This time, the most straightforward way to calculate that red length is to use tangent. So we know that the tangent of 10 degrees is equal to the length of the opposite side over the adjacent side. The tangent of 10 degrees, I got to calculate that, is 0.176. Since we're using this 10 degrees, the opposite side is the red that we want. And the adjacent side is 4. And so doing the algebra, you get that the length of the opposite side is 0.176 times 4. And so that's 0.704. Now you have to think about, so we have the absolute value of the x-coordinate. That's 4. We have the absolute value of the y-coordinate. Now we have to think about the signs of those. This point P is in the location of, is in the region of positive x values. So our P coordinates are going to be positive 4. And it's in the region of negative y values. So this is going to be negative 0.704. Let's do one more example together, and hopefully this stuff is making sense. So this last example, our coordinate system is this. And we're given that our point P is over here, and its coordinates are negative 4 for x, positive 6 for y. And what we want to do is calculate this angle theta. Okay. So to make a right triangle out of this, to make sense out of it, here is what we know. The length of this green side is 4. Let me draw that a little closer. Okay, so that length is 4. I'm throwing away the negative there because we're just looking for length of these sides. The length of the red side is 6. And so how are we going to calculate that angle theta? Well, we know that, okay, so what we want to do is calculate this angle theta. Okay, well, pause the video for a second and see if you can figure out what that angle theta is. So the way we want to do this is we're given these lengths. We know that the tangent of theta is equal to the opposite over the adjacent from SOHCAHTOA. And so the tangent of that angle is the opposite length, 6, divided by the adjacent length, 4. And now we're going to use inverse trigonometry. So if I take the inverse tangent of this, I'll do the inverse tangent of the tangent of theta. The inverse tangent of the tangent just gives us that theta. And we had to take the inverse tangent of the other side of this equation too. So we have inverse tangent of 6 divided by 4. Now you can plug that in to your calculator. Inverse tangent of 6 divided by 4 is 56.31 degrees. So as you can see, the idea here is that with just that memory device SOHCAHTOA and keeping track of what the x coordinate and y coordinate signs are, plus minus signs, I mean, not the trig signs, you can do anything you need to do relating lengths and angles to coordinates.